Hello friends, so today we solve the problem of Leetcode, which is unique binary search tree 2. So let's try to understand the problem and see how we can approach it. So we are given an integer n and we have to return all the BSTs. Okay, so what actually the question says, let's just understand it. So see, we have n is equal to the 3. It means we have total 3 values, which is 1, 2 and 3, and we have to create BST from these values. Firstly, we have to understand about BSTs because that is the major concept of this problem. So in the BST we know if there is a root node or if there is a node, so everything in the left is less than that and everything in right is greater than, or we can say sometimes it is equal to that. Okay, that is fine. So we have to create unique BSTs using this as our data, using this as our data inputs, we can say. Then how we can create it? Understand it carefully so that you can understand how we can approach it. So, as we know very well that the input data we have is sorted because whatever the n we have, if it is 5, we have 1, 2, 3, 4, 5. So, everything is sorted. So, if I am saying I am at some point which is there, so whatever present to its right is actually the part of its right in BST as well. How? See, if I think my this one is my root node, so we know the concept of BST, everything at the right is greater than that. So it is almost clear, that we are at 1 and what is present to that left is the BST left and what is present to that right is BST right. So here we have 2 and 3 as our right thing which is present at the right side of BST, but in the left we have nothing, so we can denote it by none. That's right. That's fine. That's our answer as well. How? Understand it. So we have to create a BST and this is a BST. Now let just explore this 2 and 3. If we have 2 and 3 as a values, let consider this 2 and 3 as a part of this array. So how we can do it? So we have two options. What are these two options? Like if we consider this 2 as our root, so what is present to right of it is the right thing and what is present left of it is left thing, which is none, right? Similarly, this is the first thing we can make from there. And if we think that 3 as our root node, at that condition, what is present at its left is the right of BST, and what is present at its right, sorry, that is left and that is right, is the right of BST as well. Okay, so it means when we are at this position, we have actually two things to go with, which is that and that. So we have two options. We have two BSTs, we can say. So what actually we have to do for this one, we have two combinations that we can create. What are these two combinations? Understand it. For one, we have that side none and that side the first option is 2 is there, none is there and 3 is there. The another option is 1, there is none, there is 3, there is 2 and there is none. It means for one we are getting these two options. That's very great thing. Now the twist comes here. See, as we can see, for if our input is 2 and 3, we are getting two different BSTs. And how we get it? Simply by changing the root, we are getting our BSTs. So what we can say, for this data, we only take one as our root. So this is our first possibility and this is our second possibility. But if we take 2 as our root, so what will happen there? Understand at this side. So if we take 2 as our root, so the concept is same. Everything at its right is the right of BST, sorry, left of BST, everything left, and everything which is right at it is the right of BST. That is the only thing. And at that position you can see there is no more input data, and at that position there is no more input data. So we don't have to explore it more. So this is our third thing. Similarly, if we look to 3, how we can create it? I think you can create it, right? It is very simple now for you. So if 3 is our root node, what is present at its left is our left, which is 1 and 2, and this is none, right? This is none. So for 1 and 2, similarly we explore as we explore 2 and 3. So if we explore it, so for 1 and 2 we have 1, everything at, so this is 1 and this is 2, so everything right is the right of BST and there is none. There is one combination and the another is there is 2, everything right which is none and left is 1. So this is the one possibility and this is the another possibility, and this possibility is called by what? This possibility is called by this thing. So we can simply attach 3 by this and 3 by this, which is another 2 things. So we have 1, 2, 3, 4 and 5. So we have total 5 BSTs which we create from that. So from there I think you get it, like we are doing some recursion type stuff, like we are at that position and we ask the right part to give me BSTs, it gives us BSTs. So what we did, when it gives us BSTs, understand it. So when we are at that position, it gives us BSTs, right, which is this one and this one. So what we do, we create a root node as 1, and whatever we are getting from the right side, which is these 2 combinations, we connect it. So first time we connect it to its right and we connect this to its right, and similarly for more. When we are at position 2, we call to its left, we call to its right, and whatever we get from left and right, we simply attach to that 2 root. And similarly for that case, when we have 3 as root, so we have nothing at right side, but we have 1, 2 as left side. So whatever the things we are coming from left side, we take it and simply just attach it to its left. So that is the whole thing. Let's come to the coding part, and I think you can code it from your own, but let's come to it. So simple as that. As you can see, uh, just work with more detail. Let's change the color. So simple as that, we are going from this part to this part. So I simply create a left and simply create a right, and we have to work within that bound. And one more thing here, let me just rub something so that I can create space and tell you more. So if this is our left and if this is my right, so if I consider this as my root first, so the left part is what? The left part is whatever present behind it, which is from 1, or we can say from starting to left minus 1. So in order to understand it more, we can say if we are at this position, So what is at the right? So if this is my left and if this is my right, so my left position is from starting to L minus 1. So from this we can say my left is start to left minus 1. And what is right for this two? It is left plus 1 from there to the right. So the right is from left plus 1 to right. Now it's good to go with this code. So similarly we create a helper function to work here. My code works through there. I will create a helper function. Its left is 1, right is n. So this is our function. Now let's just understand this major concept which I will tell you. So we simply do, we call wherever the position I am, because I create a for loop so that I consider each and every input data as our root. Like in 1, 2 and 3, first we take 1, then work, then 2, then work, then 3, then work. Similarly here. So first we take 1, call on its the left part, call on its left part to recursion, and the recursion gives us the left subtree, the right subtree as we see. Now in the left subtree, what are the combinations present in left subtree and what are the combinations present in right subtree? We take all these combinations. So see, the node 1 is what? It is the left combination. Right is what? It is the right combination. So we will create a root as our I is 1 initially. So whatever present to its left, we will append, which is root dot left, and what is present at its right, we will append, as you can see. And after that we will create our root, we will create our BST when our root is 1, and simply whatever the root of that BST, we append it to our answer, because as you can see the format of answer, there is an array, and within that we have all those BSTs, and the way it will write like this, the compiler will do in backend. You don't have to think about it. You simply have to append the root of that BST, and this is the solution for that. Let me just submit it, and after submitting it, uh, okay, so it will accept it. So thanks friend, and bye bye.